Welcome. How you doing? This is our fourth video for Khan Academy this week. We're going to be focused on this fourth assignment called One-Step Inequalities. I'm going to jump right into the assignment and take a look at a few of these examples. Because one-step inequalities only take one step, they're pretty quick. For that reason, Khan Academy has given you 7 questions to practice through on this assignment. So, our first example says 17x, and I'm going to write this on my whiteboard. Let me make that a little larger first. It says 17x is greater than negative 17. So as I write that onto my whiteboard, 17 multiplied with whatever x is needs to be greater in value than negative 17. I'm going to go ahead and draw a line through this inequality, the river. And our skills for solving equations are super helpful for solving inequalities. We can use the same system, the same steps, and it's almost exactly the same, but now we're solving inequalities. There's a couple little tricks with inequalities we'll get into, but largely you can use the same steps that you use to solve equations to find solutions to inequalities. Our goal, remember, when we solve equations or inequalities is to get x all by itself. Here the x is on the left side, it's multiplied with 17, so the way I'm going to get rid of multiplied with 17 is I'm going to divide by 17. That would cancel out the multiply by 17. But if I change one side of the inequality by dividing by 17, I need to change the other side in the same fashion. It's largely the same rule from solving equations. By dividing both sides by 17, this simplifies my inequality and tells me, well, x, now that you've gotten it all by itself, x is going to have to be greater in value than negative 17 divided by 17. A negative divided by a positive makes a negative. Any number divided by itself makes 1. So when we divide both sides of this inequality by 17, that one step simplifies the inequality to say x needs to be greater in value than negative 1. So if you're going to go plug that answer in, x needs to be greater in value than negative 1. You'll see here their tool pops right up. You could use your keyboard to show that greater than less than symbol, and they also pull a tool up right here that lets you easily go ahead and plug in x is greater than negative 1. Go ahead, hide the whiteboard for a second. We'll check if that answer is correct, and then we will keep moving on to the next question. Looks like we got that one, so we're going to move on to our next question here. So now we see this inequality. It says negative 12 is less than or equal to 44 plus x. So this inequality states negative 12 has to be less than or equal in value to whatever 44 plus x makes. Again, my goal when I solve inequalities is much like solving equations. My goal is to isolate the variable or get it all by itself on that side of the equation. In this case, our x is located in the right expression. I want to get rid of the positive 44. And the opposite of a positive 44, or of adding 44, would be to subtract 44, or a negative 44. Any change I do to one side of the inequality needs to happen on the other side. So when I subtract 44 to get x all by itself, I need to figure out the value of negative 12 minus 44. Whenever I combine two negatives, it's a lot like adding, but on the negative side. So if 44 and 12 makes 56, then negative 12 minus 44 is going to make negative 56. I'm going to go ahead and plug that in for my inequality here. It says negative 56, and I'm going to use the less than or equal symbol. Now I'm going to plug in my x, and we're all set. Okay, our next question. And this is the one example where inequalities are going to get a little bit tricky. It says 15 is less than negative 5 multiplied with x. And the first thing we want to recognize here, we want to isolate x. We want to get x all by itself. So I'm going to do the opposite of multiplying by negative 5, which is to divide by negative 5. And I'm going to divide both sides of the equation by negative 5 because that's the opposite of multiplying by negative 5. When I divide both sides of the equation by negative 5, I get x. This symbol I'm going to bring straight down, the less than symbol, and 15 divided by negative 5 is negative 3. So I'm going to go ahead and test negative 3 is less than x, and I'm going to see if that's correct. And I see, let me hide my whiteboard for a second. I see here that Khan Academy tells me not quite yet. And I'm a little confused because I thought my work was okay, so I'm going to go ahead and hit get help and try to make sense of this. So they tell me to isolate x, let's divide both sides of the equation by negative 5. That's the same thing that we had done here. We see we had divided both sides by negative 5, so I'm saying, okay, that's good. And then they say, remember that when we divide or multiply an inequality by a negative number, we have to flip the direction of the inequality. So you see, when they divide both sides by negative 5, they flip their sign from a less than sign to a greater than sign. So this is an important rule when I'm solving inequalities. I'm going to highlight it right here on the whiteboard. Whenever I multiply or divide both sides of the equation by a negative number, because I'm doing the opposite to the entire equation, I need to take the opposite inequality sign as well. Anytime I go ahead and divide by a negative number on both sides of an inequality, that inequality sign is going to flip its direction. Kind of think dividing by negatives or multiplying by negatives, I get the opposite sign. Very quickly, I'm going to show you an example here that says why that needs to happen. If I said 10 is greater than 5, that would be a true statement. 10 is larger than 5. But if I divide both sides of this inequality by negative 5, just like we did in our earlier example, 10 divided by negative 5 would become negative 2. 5 divided by negative 5 would become negative 1. And in this case now, negative 2 is not greater than negative 1. Negative 2 is in fact less than negative 1. So here's some of our numeric proof about this one trick we got to learn, which is that if I divide both sides of an inequality by a negative number, I need to flip the inequality sign. So hopefully that makes sense. That's a key thing that tricked me a lot when I worked through this as a student, and still tricks me occasionally today. I need to flip that sign for inequalities whenever I multiply or divide by negative 1. Now that we've got that correct, we'll keep practicing. We'll see a couple more examples. So here we see negative 18 as our inequality. And I'll make the whiteboard a little larger again. Give me a second. It says negative 18 needs to be less than 9 times x. So whatever 9 times x is needs to be greater in value than negative 18. Or the other way around, negative 18 needs to be less than whatever 9 times x is. I could solve this by getting rid of the 9. I want to isolate the x. It's on the right side of the equation. And the opposite of multiplying by 9 is to divide by 9. Dividing by 9 cancels out the multiplied by 9. Negative 18 divided by 9 equals negative 2. Here it's important to know I did not divide by a negative number. This is a negative value over here, but the sign, the inequality only flips if we divide by negative numbers. Here we divided by a positive, so the sign is going to stay in the same direction. In this case, negative 2 needs to be less in value than whatever x is. Or another way to think about it, it's saying x needs to be greater than negative 2 if you flip the inequality around. We're going to take a look at a couple more examples. This one we're going to run through kind of quickly. It says negative 36 plus x has to be less in value than 8. Here, if I draw my river, my line through the inequality sign, the x is in the left expression, the left side of the inequality. So I want to get the x all by itself by getting rid of negative 36. How do I cancel out that negative 36? Hopefully you're recognizing I need to add 36 to both sides of this equation. And that tells me x needs to be less in value than 36 plus 8, which gives us 44. So here, x needs to be less in value than 44. And hopefully we're going to find one more example. Perfect. The last one we're going to show you as a group, actually we'll show the last two, we're only down to two. It says negative 7 times x needs to be greater than 10. Here, a couple things. I see the x is on the left side of the inequality sign, the left side of my river, so I'm going to go ahead and get rid of the negative 7 that's multiplied with that x. The opposite of multiplication is division, and I'm going to remember something important from the earlier mistake I made. Whenever I divide by a negative number or multiply by a negative number, the inequality becomes its opposite. So I need to flip the sign from greater than, in this case, to less than. And this is now going to be negative 10 divided by 7. Negative 10 does not get divided evenly by 7, so I'm going to just leave my answer as a fraction. That's totally fine. X is going to be less than negative 10 divided by 7, or the fraction negative 10 over 7. One more question, one more example to show as a group. As always, Khan Academy, they love to put tough ones that are very tough at the beginning. Sometimes we see an easier example towards the end. Here it says, whatever 2 times x is needs to be less than 15 in value. If I don't know what number times 2 will always be less than 15, I could divide both sides of this equation by 2. By dividing by 2, that cancels out the multiply by 2. 15 divided by 2 gives me 7.5. So I could say x needs to be less than 7.5. That sign, that inequality won't flip when we divide by a positive number. I'm actually going to leave my answer as a fraction. I'm going to put the fraction 15 over 2, which is the same value as 7.5. And it looks like Khan Academy will accept both fractions and decimals when you don't have an integer or whole number answer for x. Hopefully that video was helpful. If you need any help, I encourage you to continue to use the Get Help features, continue to watch Sal Khan's videos, and always feel free to email this guy, and I'm happy to jump on Google Meet and figure out some stuff with you one-on-one. Thanks for watching to the end of the video. Keep up the great work.